In 11 we derived the Fourier transform of x of 2n. So the problem itself has broken up the derivation into small steps. So first set up the Fourier transform as a sum over n with no simplifications. So the Fourier transform is supposed to be sum over n going from negative infinity to infinity. The function x of 2n e to the negative j omega n. That's what this is. Now this is over all values of n. We need to substitute something else for n so that the sum is over even values of the variable m. So what this means is if we substitute 2n is m, then it becomes x of m e to the negative j omega n is m over 2, but the m's are only the even values. So although this looks nice and similar to the Fourier transform, this n is supposed to be over all n. Here the m is only the even value, so this is not yet usable. Here he's asking you to replace this guy with g of m xm, where g of m is 1 for m even and it's 0 for m odd. So how can we write such a function g of m which is 1 for an even number, 0 for an odd number? Such a g of m is given by 1 plus e to the 1 plus minus 1 to the m over 2. So every time m is even, this becomes 1 plus 1, which is 2 over 2, which is 1 for m even. Anytime m is odd, this is negative 1, it becomes a 0. The whole expression becomes 0. So 0 for m odd. So this is something that satisfies this equation, and it's possible we'll be needing another simplification, which is minus 1 is actually e to the j pi, right? E to the j pi is minus 1, and so is e to the negative j pi. So we can write g of m as 1 plus e to the j pi m over 2. Now all we need to do is substitute it here. We say m over all values. The function has been replaced by this, so it's going to be 1 plus e to the j pi m over, so it is sum over m over all values of m, gm times x of m e to the negative j omega m over 2. That's from before. Now this can be split into two separate sums. So this is just half times xn e to the negative j. I'll write it as omega over 2 m plus half times sum over m going from negative infinity to infinity xm e to the negative j. Now it's omega over 2 minus pi m, right? This is m times omega over 2 minus pi. So the Fourier transforms of these two would be half times, this is x e to the j omega over 2, if you remember. Whatever that is appears here, plus half times x e to the j, that appears here, omega over 2 minus pi. So that's the answer. Although this is complicated, this is a one of a kind situation, and if it appears on the exam, it will be in a similar format where you're given hints on how to proceed, but you ought to know what to do in this portion.